Hey, I'm going to give you a short little video that talks about how we find some information related to geometric sequences. So let's just start off with a little bit of vocabulary for your ed puzzle here. So when we talk about geometric, we're basically saying a sequence where I have a set of numbers. Let's give you one here, 2, 4, 8, 16, 32, ... And to go from one number in my sequence to the next, I have to figure out what the pattern is. And instead of it being an addition problem, in this case, to get from one number to the next, I have to multiply. So, sorry about that. In this case, I'm multiplying by the number 2. 2 times 2 is 4. 4 times 2 is 8. Hopefully this looks like a little multiplication sign. 8 times 2 is 16, etc. So we call this number right here the common, instead of difference, which we would call it in arithmetic, we call it the common ratio, or sometimes we call it the common multiplier. So that gives you a little idea about what we're going to talk about. And we're actually going to look over here at this set of numbers and figure out what the sequence is. So I'm going to erase this to give myself room without having to scroll over. And let's take a look at the sequence that starts off with 2 and then goes to 2.2 and then to 2.42 and 2.662. If I'm trying to find the common ratio for that, and I can't just in my head go, I don't know, like guess and check, one way you can find it is to take any two numbers in the sequence and divide the second one by the first. So in this case, I'm going to pick 2.2, and I'm going to divide it by the first number, which is 2.0. If I do that, 2 goes into 2 one time, bring down the decimal, 2 goes into 2 1. So it looks like to get from 2 to 2.2, I have to multiply by 1.1. Let's check that and just do the next set and make sure if we put in our calculator 2.42 and we divide it by 2.2, use your calculator, let's make sure that also gives us 1.1. So I'm just putting it in, and sure enough it does. So my common ratio in this case is 1.1. To get to any number in there, I got to multiply by 1.1. So let's figure out the fifth number then in our sequence. So to get to that, I take 2.662 and I multiply that by 1.1, and that's going to give me 2.9 and then a bunch of numbers that I'm going to round up to 3 just to keep it simple. So this is 2.9282. And I'm just going to say, oh, this 2 right here, I want to go to 2 decimal places. Okay, well, let's bump that up and call it 2.93. So once we know that, let's talk about the explicit form. We've been talking about this for arithmetic sequences. Let's see what happens with geometric. So in this case, we kind of start off the same. We have this idea that to find any number in the sequence t of n, we're going to need to understand the common ratio, and we're going to need to understand, so we're going to call this, instead of common difference, we're going to say common ratio. We'll call that R. In this case, we know R is 1.1. We also need to know t of 0, our start value. Sorry, my handwriting's bad. And for a geometric, we're going to put this little multiplier in here, and we're going to say that there's an exponent in there, n. So t of n, to find any number, I have to know what the start value is for my sequence, what t of 0 is, what my common ratio is, and then take it to the power of n. So here I already know what my common ratio is. It's 1.1. But I need to work backwards now to figure out what my 0 value is. So if I want to figure that out, I got to say, oh, okay, well, it's 2.0. Instead of multiplying by 1.1, let's go ahead and divide by 1.1. So let's put that in our calculator. And if we do that, we're going to get 1.818, and it keeps going. So let's round that number and say that it's roughly, our t of 0 is roughly 1.82. Whenever we're dealing with decimals, it's good to have some idea of what significant figures we want. So I'm going to now write, so my explicit equation, t of n, to find anyone in there, I'm going to have a start value of 1.82, and then I'm going to multiply that by my common ratio of 1.1 to the power of n. We can actually check that too and make sure it works. I'm going to scroll down and let's double check. Let's figure out what we said. We already knew what t of 3 was, but let's put it in our formula and double check it. So we get 1.82 times 1.1 to the power of 3. If we put that in our calculator, we know that it becomes 1.82 times 1.331, and then we multiply those two numbers in our calculator, and we go, oh, sure enough, we get 2.42. And that should look familiar because there it is, 2.42. Right here. So there's our explicit. Let's talk a little bit about our recursive, and then we'll be done for this video. Thank you for joining my ed puzzle for today. I know it's a little bit longer. I thought that it'd be good to do an ed puzzle that's a little longer. So to find a recursive for an explicit, for a geometric, we always say t of n plus 1, the next number in the sequence, it's got to be equal to the current number in the sequence, and then this time instead of adding a common difference, we're actually going to multiply by the common ratio. And it's always good also to give a t of n value. So let's say for this case we want t of n plus 1, we have to know t of n, and we have to times that by 1.1. And we can give the added piece of information that t of 1 is 2. And that right there is your recursive formula. So go back and make sure you've answered all of the questions that go in this ed puzzle, and I hope this helped understand a little bit more about geometric sequences.